It means that whatever I wrote here implies what I'm going to write on the other side. And whatever I write on this side implies the left-hand side. So it's a double proof. This implies this implies that. So the limit as x approaches a from f of x is L is equivalent to saying for every epsilon positive, there exists a delta positive. I'm going to continue here, such that every time I pick x with a distance of delta away from A, this will always imply that the distance between f of x and L must be less than epsilon. This is the epsilon delta definition, not all this. I was trying to write it with you step by step so you understand where I'm coming from. But that's not what we write. It's useful so that we can keep up with the steps. So for every epsilon greater than 0, I will find a delta greater than 0 such that every time I pick x, the distance between x and A, I pick an x with a small distance from A, smaller than delta. But what does this mean? Why do I need to put that the absolute value is greater than 0? The absolute value is always greater than 0. Why do I need, isn't this redundant? Why did I write 0 less than the absolute value of x minus? In other words, the absolute value is greater than 0. Why? What am I trying to avoid? I'm trying to avoid equals 0, which means I can never pick A. I can never replace x by A because x approaches A. So in other words, this can never equal 0. This will never equal 0 because x will never equal A. So that's all it means. So this specification says I cannot say that I pick x to be A, because we know that this symbol means automatically x not equal A. So that's what this is for. So for every epsilon, I'll find a delta also positive such that the distance between x and A will be always less than, when I pick x close enough to A. How close? Not more than delta. Close. Not more than delta. F of x, f of this x minus the limit will always be less than epsilon. In other words, this value of f of x will fall close enough to L, closer than epsilon. Why? Because the limit exists. Otherwise the process will not work. So let me give you a counterexample, and then we'll show a proof. So let's say I have this function. Can I say that the limit of f of x as x approaches A is L? I think I heard a no. Of course I can never say something like that, because the limit from either side is not the same. This does not exist. And you could say, but this is, you can still determine the delta. Let me show you an example. So this is L plus epsilon. This is L minus epsilon like before. I draw horizontal lines. I draw horizontal lines. I find the corresponding x values. And I'll choose the smallest of the two. let's say one or the other, it doesn't matter, and I pick x here, and it falls within epsilon. And I pick x here, and it falls within epsilon. And I pick x here, and it falls within epsilon, and I pick x here, and it falls within epsilon. So the limit exists. No. No, it does not. Because the definition says for every. I only showed you a particular example when I used a huge epsilon. But it doesn't work for all. If I choose this epsilon, I will never be able to find the interval. The interval doesn't exist. It's a value. So I have to be able to show you for every epsilon. Small, big, medium. It doesn't matter. But I cannot show you for all epsilon because the limit does not exist. So this is a key element for every epsilon greater than 0. Okay, so now I'd like to look at a numerical example. And be careful, I'm not sure why, maybe it's my printer. But when I printed the exercises 2.4, so to work on different examples with you, the graph didn't appear. So I may have done something. I can go back and see what I did. I'm not sure why, because maybe just this page or on other ones the graph is there, but I don't know. Okay, so I would like to look at this problem number 2 from exercises 2.4, and I'm going to copy the graph for you here. So they're giving us this graph. Oh, I'm sorry. Let me say, do you have any questions? You know that is always true. I don't want to move on if you have any questions. So you can always ask, please. So they're giving us this graph. They say that this is 3. They say that this is 2. They're showing us 2.5 here, 1.5 here. They're showing the horizontal lines. They're showing us 2.6 and 3.8. And they're giving us, and be careful because there is a typo here. So they say use the given graph F to find the number delta, but then they write D here. So it's a typo in the book. So it's delta, it's not D. It has nothing to do with what we're talking about. It's the epsilon delta definition. So this is delta. So 0 less than the absolute value of x minus 3 less than delta. And that will imply, of course, f of x minus 2 less than 0.5. So they say for the given graph, find delta. Can anyone identify, first of all, the limit for us? Let's go slowly and identify different items. So can anyone give us the limit? Can you still see? Let me know. Can anyone identify A? This is the function, but we don't have it. We don't have the algebraic expression. Anyone?
3.
Which one?
No, I meant tail. The L.
Yes, the L is 2, of course. And A is, of course, 3. Very good. Excellent. And can anyone identify epsilon?
0.5.
Excellent. Do we all agree so we can move on? If you don't agree, then I have to stop and explain again why, where are they coming from. Okay. So now, with the given information, we obtained this with this distance, let's call it delta 1. And we obtained this number, which is 3.8. They were given it to us. And I get a delta 2. delta will always be the minimum of the two numbers that we come up with. Can anyone tell us what is delta 1 and what is delta 2? What are they equal to?
Delta 1 is equal. No, you go. I'll be quiet.
Delta 1 looks to be negative 0.4, or is it the opposite?
Very good point. Very good point.
Okay, so it's positive. Yep, you said that earlier. So it's
That's
positive.
okay. That's okay. And the other one?
0.3.
Anyone? What is the other one?
1.8.
Very good. And we know what happens. We know which one we have to pick and what is the answer. 0.4. That's it. Great job. Now, how do we do this in general without numbers? So let's look at a limit. Give me a linear function. Any linear function you can think of. And let's calculate a limit and then prove it using the epsilon delta definition. A linear function, anyone.
X squared.
That's not linear.
2x.
2x. Let's say minus 4. And give me an a. X approaches.
3.
Excellent. What is the limit, please? Excellent. Let's start. So the question is asking, let's write what the question is asking us. Prove using, epsilon delta definition that the limit is 2. Prove this using the epsilon delta definition. Okay, so that implies for every epsilon positive, I will find a delta positive such that 0 less than delta. Please tell me what to write in here. Give it a shot.
X minus 3.
Excellent. Good. Less than delta. This will always imply what do we have inside of this? Absolute value. Anyone? Look at the definition and tell me what to write. Give it a shot. It's okay if you're wrong. Right, but I have to put in the f of x. It's no more a generic f of x. We have f of x.
2x minus 4.
Very good. Minus 2 less than epsilon. Well done.
Okay, y minus 2? Oh, because L. Never mind.
That's fine. That's why we established, we should have established those for them again. Good. So here is our proof. Here is our starting point from here. And we want to eventually get this. I'm trying to keep all these devices working. Okay, so 2x minus 6 less than epsilon. What do you think? Keep in mind that this is where we are going. What do you think I'm going to do here? I want to get something like this. On this side, I need this. I don't care what this is, but I care that on the left-hand side, I have the absolute value of x minus 3. What should I do here inside?
Factor out of 2.
Very good. Awesome. That's the only option. Oops. Good. Be careful now because you cannot, there are specific properties of the absolute value. You cannot move 2 in front. You have to write this step. It's a mandatory step, which means the absolute value applied to a product is the product of absolute values. And this is what I have to write first. You can say it's redundant because the absolute value of 2 is still 2. It doesn't matter. You have to write this first. Then you have to write this. Remember where am I going? And what should I do now to both sides? Which I couldn't do before. Final step. What do? I need to obtain this on this side. So what can I do? There is nothing else but one.
Divide by 2.
That's it. There is nothing else. So by comparison, if you compare this to this, have we found delta? And how much is delta? And remember, we said that from the very beginning. For every epsilon, I will find the corresponding delta. Delta depends on epsilon. If epsilon is 0.1, maybe delta is 0.3. If epsilon is 0.2, maybe this is 0.03. So delta will always depend on epsilon.
Professor.
Yes, please.
So you said, I get that delta depends on epsilon, but what you were showing us in that graph a couple pages ago was that there's delta 1 and delta 2, and you always choose the smaller one.
Correct, but we don't have numbers now. So we cannot do that procedure. This is a general procedure.
Okay.
That will give us the correct delta from the get-go. I'll give you some examples if you choose, but let's identify delta because I have to write step 2 and then I can show you different examples. We don't have epsilon, so we don't have 2 different deltas. So how much is delta then? What do you think? If by comparison, what can delta be? If I have the absolute value of x minus 3 on the left-hand side, if I have the less than, if I have delta and I have epsilon over 2, what can delta be?
Epsilon over 2.
That's it. Of course. There is nothing else. As long as I obtain what I wanted, there is nothing else. But I have to write step 2. Why? Because of the double equivalency. From here to the right and from right to the left. And we are just going to write one sentence. I'm not going to make you go reverse the steps. It's good enough.
Put epsilon over 2.
I'm sorry?
Is it supposed to be epsilon over 2 or epsilon over 3? For delta.
We have epsilon over 2.
Okay.
Epsilon over 2. Do I have a 3 somewhere and I don't see it?
No, you're fine.
You may see something that I don't, so always stop me if there is anything. So in step number 2, show that delta equals epsilon over 2 works by reversing the steps from above. I'm not going to ask you to do those steps, but you have to write this sentence. Done. So now, if I say epsilon is 0.1, you will say no problem. Delta is 0.1 over 2. If I say epsilon is 0.02, then you'll say no problem. Delta must be 0.02 over 2, and I can go on forever. Any questions? Now I'm going to ask you whether we need another example, a numerical example or a non-numerical example. Or we got the picture and we can move on.
This is section